All right, so this is my recording for Project 3, Storm 3. I'm going to try to run through three different data structures and just kind of show that it is sorting and doing a few different things. There's about three general data structures that we're working with, and that's the collection map and the Storm AVLTree. And amongst those general ones, except for the Storm AVLTree, there was some slight things we had to do here and there to make sure that they behave properly for the kind of data structure that they were. So we'll go ahead and start with, let's see, we'll go with just an array list, I think, first. So we'll go ahead and start. At the beginning, the Storm 3 is going to prompt you to ask how you want it ordered. And we're going to go ahead and order it by state, because I think that makes it easiest to tell if it's been sorted or not. And we'll tell the computer that or the program that we would like to see an array list. And we'll give it the file. I used a slightly smaller, not smaller, but just a truncated version of the normal CSV file that we would normally be reading through, just to make things go a little bit quicker. So we'll go ahead and just put out the output to the console. And then we can see that it is in fact in alphabetical order by state, so that's good. We'll go ahead and resort it. And let's see, we'll go by event ID. Now, whenever I give this thing, I'll show you how the custom comparator works here in just a moment. But we'll go ahead and, it says it's not a correct selection, but you can see up here that it told us that we're sorting, told us what we were sorting, and then it told us how long that function takes. It does that for basically any of these selections down here that the user is going to put in there. So we'll go ahead and do another output. You can either just put O, or you can put you can write output in full, and it works either way. So here we can see that we're sorted by our ID. Let's see. We'll try to get a summary of this, and we'll tell it that 2019 is the year we're going to look, because I think that's the only year included. Again, I have this problem where it seems like it'll consume one extra entry for some reason, but it allows us to keep on going. So let's see, direct injuries 1. This is correct. I checked against Storm 2, which I was know worked both in the truncated and the full version, and I know that this works in the full version as well. So so that's pretty much it for the array list. It'll do the other things like find and delete and all that stuff fairly easily. Let's see, we'll go ahead. I'll try to keep this video from being like 40 minutes long. We'll go ahead and try HashMap. Here we go. Let's get another shot here. We'll go by state. We'll go to HashMap, and we'll get the same file. And let's see, it tells us how many's been read. And we're going to print this to the console because it's easier to see. Alrighty, so we can see here also that this has been put in order, in alphabetical order. And then there's the header. Let's see what else we can do. Let's see, we'll go ahead and get a summary of it, and we'll tell 2019, and that is the same that we got from the other one, so it's all working correctly. And then we'll go ahead and resort it, and let's see, we'll resort it by the event ID. It tells me that that's not true, but again, that's just, for some reason it does the thing twice. And we'll go ahead and print this out again. And here we go. This implementation seems to not. Oh wait, yeah, no, I'm looking at the wrong thing. I'm sorry. I was looking at the wrong thing. I was like, oh no, it's not in order, but it is. All right, so here's our order here. It does end with these right here, and I think that's because these are different parts of the tree, and so I try to do something that would take out a specific part of it and reinsert it at the top, and it seems to have worked poorly there. So I do need to probably, if I have some more time, I would definitely want to re-implement that better. Alrighty, so that's those two different kinds of data structures. We'll go ahead and check out this AVLTree. The AVLTree I actually got from Princeton. And right here, I've had to adapt some of the code so that it worked better with our code, but the Princeton author here, this is a really great data structure. I've enjoyed studying it at least, and I had to use Q. I had to use Q for Q class from Princeton as well. So we'll go ahead and go back to Storm 3, and we'll run it again, and we'll use this AVLTree. The big thing I've definitely learned working with data structures here is just how to optimize each one of them. So some of them I prefer to use iterators, but others would be better if you use a get function for them, such as like the hash tables or all that. So anyways, I'm rambling here. So let's go ahead and we'll use state, and let's see, we'll do the AVLTree, and we'll tell what file, same one, and let's see, so the size is appropriate. We'll go ahead and put the output and console, and there it is, arranged correctly. We'll get a summary of it, and I've actually enjoyed myself coding, trying to learn how to use all these different data structures. And then we'll go ahead and resort it. And we'll sort it by event ID. And told us that it sorted it. And go ahead and output it to the console. And there, once again, it's sorted. So that's basically all the functions. So I'll talk a little bit about how I've implemented some of these things. This code is like over 1,000 lines long, so I guess I really can't go through everything, but I did want to talk shortly at least about some of the challenges of implementing it here. So priority queue here, I had to do a few things. Priority queue you can't actually feed a custom comparator to, but you have to iterate, no, not iterate through, sorry, you have to retrieve the data and then feed it back to it in order for it to get in order for it to print out properly, because you can only use poll or remove to get items in order, but if you just go use an iterator, it gives you a different kind of order, probably the order that it was initially in, but you can use a comparator to keep the data in order if you use poll. So what I had done to implement priority queue in various places was I would pull things into, I'm trying to think how to put this. I would pull things into a new queue, I believe, and print them as they were pulled if it was going to the console, or write it as it was pulled and send it to the other, and send it to a file. So this would kind of solve the problem. The only downside is that you would have a data structure or a priority queue that was growing as it was pulled, or not as it was pulled. It was growing as you inserted the data that was pulled from the initial priority queue, and then you'd replace it, and then after that I would just set the temporary priority queue to null afterwards. ArrayList, I had to do some changes to the code. I did a new add element. This is based on the linked list that we had done for Storm 2. And so there was some stuff around here that allowed me to feed comparators to this array list so that the add would work in a specific way and allows us to compare in specific ways based on a comparator. Let's see, we'll get back here. I'm sorry, and I'm trying not to make this too long. So the reason we have so many different choices here for these switch cases is because there's 3 different ways that we can order this by state, episode, state, episode ID or event ID, and year. Now, I've made a custom comparator that will actually allow us to basically do anything based on what the user, how the user wants to order it. You can actually use any field that's available, and the way that this works is that it'll take the custom comparator can take an int, and that gives us the field number that they're interested in. We feed that field number into the custom comparator, and what it will do is it will make the compare, it'll override compare and allow it to add whatever that field number is they want to order it by, and then add the event number, which is the 7th field. It'll add that number to the field that they want to sort by. So if they want to sort by state, it would actually be state plus the event ID, because states are going to be recurring, so we don't want to have either a key or just a regular sort that is using the same thing but doesn't have some type of other hierarchical decision making that it could possibly pull from. So this will allow us to make custom comparators for basically any field, but the three main ones that we do are the state, let's see, the state event ID and year. So that's what these switch cases are if the user decides to do 1, 2, or 3, which is one of the three choices based on what they have made earlier in the code. And so here you can see that I'm feeding the custom comparator to all these different data structures. However, stuff like the maps, they actually use a different way in which you can give it a different key. So what I did in that case was for weather event, I added different ways that we can do keys, right? There's a default order key, which is just the event ID, state order key, which is the state plus the event ID, then the year order key, which is the year plus, and then the custom, which allows us to do whatever we want if we want to use some other kind of comparator, which is important later for the sort function. So add, put, and put, those are the different ways that these different trees, the AVL tree behaved in essence like in some like a map. And again, the AVL tree was very, very interesting. Let's see, I'm trying to make sure I've got if cases for most of these. So if coal, which is collection, is not null, then it allows us to do this particular thing. And then if it's a map or if it's an AVL tree, it'll do a different thing. Reader count is basically just to count how many times the reading loop has executed. That way we know that if the size and the reader align properly, then we know that these two are the same. That it actually did pull all of the items that we wanted. It did read them all. Let's see, Storm ArrayList. Yeah, so Storm ArrayList was interesting. We could, in these cases, yeah, because we have to do different collections. Sorry. With the add here, allows us, this is basically putting the header back at the top of our collection or our map or whatever. This is inserting it at the correct place. Other collections, you can just add the data header, it'll automatically be at the top. Let's see, map, yeah, you can just tell it that I want to use the key 0 in this case, because I know that would be the earliest key, and therefore it would be at the top of the data structure. Let's see, yeah, this is, sorry, I've got, yeah, this is state order. Okay, yeah, this is just the different orders and tells it how it's going to add it, depending on which key that we're using. So these are just the different choices. Let's see. Now, down through here is where some things kind of get more interesting. This is priority queue. Whenever we go to put something out, like I said earlier, we can't actually, you can't actually just iterate through the priority queue, because in that case it would not look as if it's in order. So what I did, I did here, I basically created a temporary priority queue, and then I pulled from the priority queue. If collection was an instance of a priority queue, I would pull from the priority queue and create a temporary weather event for that. I would print that out, and then I would add it to our temporary priority queue. And when this is completed, when it goes to the entire priority queue in which the original one would be empty, I would basically tell it that it should have the same elements as temp, and then I reset temp to where temp is now an empty data structure to save some space. I believe this takes longer than normal. I've got counters at the beginning and end of every one of the selections that the user can make. Yeah, so most data structures you just iterate through. Let's see. Yeah, so if this is a HashMap was pretty interesting to work with. So a HashMap doesn't actually maintain orders. If you just print it as it is, it does not maintain this order. So instead, what I've done is that you can get the key set from it, and I've used an iterator to go through the key set. And I would use that iterator basically to add it to this array list, and that would put it in order, and then it would print it back in order. So HashMap is good for storing. It's easy to retrieve things from it. It's easy to add things to it, but it takes a lot to try to get things back into order. Let me see. AVLTree is sort of similar, except you don't have to make. I had to make weather keys for that to iterate through it in order for it to print those out. Let's see. Find wasn't too bad. Oh, sorry, this is file output. Yeah, this is how they write. I'm sorry, I was looking at the wrong function. Most of these aren't quite as interesting. There's a few that had to have specific treatments, such as AVLTree here for our summary selection, because we have to iterate through it. But most of these are actually using iterators as well anyway. Although I guess this is not optimized, I don't believe, for ArrayList, which you can actually grab things from a specific index, so you might be able to do that a little bit faster. I definitely wish I would have had a bit more time for this, but I have learned a lot about data structures through this. Find selection, yeah, most of these use iterators. Try to find stuff with outliers. Deletion, iterators. Yeah, that's pretty much it. There's big things that I had to do. Well, sort is more difficult, but required a whole lot of changes here. So for tree sets, you had to have a certain way of reordering it, and same thing for tree set and the priority queue and all that. Those had specific ways that they had to be reordered that were different from one another. ArrayList here, basically I just used the sort function from ArrayList because ArrayList has a sort function. So that one was quite easy, but the rest of them had to be iterated through. Let's see. Yeah, HashMap and tree maps. These are different ways of sorting them. I believe that's basically what all this does. Yeah, this down here is basically for the deletion confirmation task that we had to do before. So I think we went through basically everything. It was very interesting to move through all of these different data structures that I hadn't used before, and it really gives you an idea of how to navigate and sort things and use them effectively. I almost certainly forgot some things, and again, I wish I had a little bit more time with the code so I can get it to stop doing things such as where it would do this right here where we failed twice. But overall, I've had a lot of interesting time working with these different data structures. Like I said, I've probably certainly forgotten things. I think there's something like, what is it, like 106? I can't remember. I've worked out how many different, depending on what data structure you picked, and then what events you did after that, whether it was sort and all that stuff, or how you sorted it. But it's so many different options. I'm sure I've forgotten something or overlooked something. But this is basically the data structure portion without the GUI of me and Jeff's project. So thank you for watching. Bye.